Welcome guys. Today we are going to solve all the numericals of class 9th chapter 8 motion, which is physics, and today we solve all the examples of the chapter, and in next stream we solve all questions which is in text or in exercise which is numerical on copy, and we got it. So let's start. So we written a first question, that is, an object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? So we know that average speed equal distance covered by टाइम टेकन। तो यहाँ पे हमने जो डिस्टेंस कवर किया वो है 16 मीटर एंड 16 मीटर, मीन्स कि 2 16 मीटर में कि 16 मीटर प्लस 16 मीटर, और जो टाइम टेकन है वो है 2 सेकेंड एंड 4 सेकेंड, दैट इज 6 सेकेंड, मीन्स 32 मीटर बाय टाइम टेकन 6 सेकेंड. So this is going to equal to 5.03 meter per second. This is our average speed. We are now solving the numericals. Please ensure you are liking the stream and subscribing the channel. So our next physics numerical is, this is, the odometer of a car reads 2400 km at the start of a trip and 2400 किलोमीटर, सॉरी ये 2000 है, 2400 किलोमीटर at the end of the trip. If the trip took 8 hours, calculate the average speed. We have to calculate the average speed of the car in kilometer per hour and meter per second. So we know that average speed equals distance by time. So यहाँ distance covered is 20 at the end to 2400 kilometer and at initial 2000 kilometer, means कि total distance covered that is 400 kilometer difference between, and the time taken is 8 hours. So the average speed is going to 50 kilometer per hour. This is average speed in kilometer per hour, or we can write it as 15 kilometer per hour or 15 km per hour, that is, in meter per second it is going to 15 km per hour in meter per second. This is going to 15 into 5 by 18. that is equal to 13.9 meter per second. 13.9 meter per second or 13.9 meter per second. And we have next question, that is next question example number 8.3. That's question number 8.3. that is new question is Usha swims in a 90-meter long pool. Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute. She covers 180 meter in 1 minute by swimming from one end to the other end. By swimming from one end to the other end. From one end to another end. Along the same straight path. Along the same straight path. So the question is find the average velocity, find the average speed and average velocity of Usha. So we have to find here average velocity and average speed of Usha. So first we find the average speed. Average speed is going to equal to distance by time, that is equal to distance covered. He covers distance 180 meter in 1 minute. So distance covered is 180 meter in 1 minute, that is equal to 60 second. We solve it in our standard form, that is answer in standard form, that is meter per second. So this is going to be 3, that's equal to 3 meter per second. This is the average speed of Usha. And now we have to find the average velocity. So the average velocity is that is displacement by total time taken, that is equals to final velocity minus initial velocity by time, that is equals to final velocity that is फाइनल वेलोसिटी इज ज़ीरो, मीन्स कि जब हम कहीं पे जा रहे हैं फिर वापस आ गए तो वहाँ पे अगर आ गए तो हमारा जो वेलोसिटी होगा, जो हमारा स्पीड होगा वो कहीं ना कहीं पे ज़ीरो हो जाएगा, और फिर जो इनिशियल वेलोसिटी होगा वो भी ज़ीरो होगा, और बाई में जो टाइम टेकन है वो 1 मिनट है, तो 0/1 दैट इज इक्वल्स टू 0 मीटर पर सेकेंड इसका वेलोसिटी। एंड नाउ नेक्स्ट क्वेश्चन 8.4। Question number 8.4, that is, now we are not going to write the question, we are but just noting the questions. Starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. So it's Rahul's initial velocity is going to be 0 meter per second, and this final velocity he attains, that is 6 meter per second. Time he takes to attain this velocity 6 meter per second is 30 second, and then he applies brakes such as the velocity of bicycle comes down to 4 meter in the next 5 seconds. Calculate the acceleration of bicycle in both cases. So in first case the initial velocity is 0 meter per second, final velocity is 6 meter per second, and time is 30 seconds. So in first case we have to find acceleration. The acceleration is equals change in velocity by time, that is equals to change in velocity ये हमारा है और ये हमारा है, तो फाइनल माइनस इनिशियल दैट इज इक्वल्स 6 मीटर, change in velocity 6 meter per second by time is 30 seconds, that is going to equal to 0.2 meter per second square. Its acceleration in first case, and in second case in second case initial velocity is 6 meter per second and he applies brakes, so its final velocity is at 4 meter per second, and this all happens in time 5 seconds. So the acceleration is change in velocity by time taken, so change in velocity is 2 meter per second into time is 5 second, 5 is, so 5, that is going to equal to 0.4 meter per second square. And we are going to the next question. Sorry, here is one mistake. Final minus initial, that is -2, so here is he applies brakes. This negative signs shows that the acceleration is applied from the opposite direction of the motion. Question number 8.5. The question is, Question is, a train starting from rest attains a velocity of 72 km per hour in 5 minutes. Assume that the acceleration is uniform. Find the acceleration and the distance traveled by the train for attaining this velocity. So first, the bus is at rest, so its initial velocity is going to be 0 meter per second, and after accelerating it for 5 minutes, it attains the velocity of 72 km per hour. So its final velocity is going to be 72 km per hour, and this also happens in time 5 minutes. And after this, we have to find its acceleration. Acceleration we have to find. So acceleration, so first we change all units in their standard form. So 72 km per hour is going to be changed in 72 km into 5 by 18, that is equal to 20 meter per second, and 5 minutes in seconds. 5 into 60, that is equal to 300 seconds. So the acceleration is going to be change in velocity by time, or final velocity minus initial velocity by t, that is v minus u is equals to change in velocity. So acceleration is going to be, that is this method, 20 meter by per second. So the by is in s is going to be under the part, and into 300 s, and this is s second. This is equals to 1 by 15 meter per s into s, that is equal to s square. This is the acceleration of the bus, and we have to find the distance traveled by the train for attaining this velocity. So for this we have to use a formula, that is 2as is equals b square. This is derived, and I can also upload video for derivation of these formulas, but now you just take it as this is a formula. 2as is equals b square minus u square. So here we have to find s, that is distance or displacement. So now we put all the values. 2 into acceleration, that is 1 by 15, and the s is s, we have to find, and v square is 20 square minus u square, that is equals to 0. So it is 2 by 15 s is equals 400. So 2s is equals 400 into 15. S is equals 400 into 15 by 2, that is 3000 meter, which is equals to 3 kilometer. So it travels distance 3 kilometer. And now we are going to the next example. So change the page. Question number 8.6, that is, a car accelerates uniformly from 18 km per hour to 36 km per hour. Acceleration and distance covered by the car. So first, we note down the questions. Tejveer Singh Parihar, please stop writing. I seen this and I am going to answer it in the last. So first, please like the stream and subscribe the channel. So the question is, a car accelerates uniformly from 18 km. So its initial velocity is 18 km per hour. Final velocity is going to, and the final velocity is 36 km per hour, and this all happens in time 5 seconds. So we have to calculate the acceleration of the body. So the acceleration of the body is change in velocity by time taken, that is final velocity minus initial velocity by time. So we first change these in standard form, that is 18 km per hour is going to be 5 by 18, that is 5 meter per second, and this is going to be 10 meter per second. So acceleration is going to be final velocity, that is 10 meter per second minus 5 meter per second by time 5 second, that is 5 meter per second into 5 second, that is 1 meter per second square is the acceleration of the body. And we have to find distance covered, that is s, and we have the formulas. So if you don't know which formula we have to put in the question, So you see that, which note down all these which are given in the question and see that only one left in the formula which is we have to find, and all are given. So we can use this formula. So here we have to find s. This is equal to distance traveled. So we use formula s equals u ut plus 1 by 2 at square. So here we have u, we have t, we have a, we have t. So we can find s. So s equals u. What is u? U are our 5 meter per second, that is 5, and t time is 5 plus 1 by 2 into acceleration is 1 meter per second square, 1 into time 5 square. So this is distance is equals 25 plus 1 by 2 into 25. So the distance is equals 37.5 meter. And the last one is example number 8.7. This is the brakes applied to a car meter per second square. The brakes applied to a car sorry, I wrote half of the question, so please don't leave the stream and see at the last. Car produce an acceleration of 6 meter. Produce an acceleration of 6 meter per second square in the opposite direction of the motion. Opposite direction of the motion. If the car takes 2 seconds to stop, if car takes 2 seconds to stop, after the application of brake, after the application of brake, calculate the distance it travels during this time. Calculate the distance it travels at this time. So we have to find the distance it travels. So it's So the in question given that acceleration is 6 meter per second square, that is in minus because it is the opposite direction of the motion, and acceleration, and finally we have to stop the car, so its final velocity is 0 meter per second, and the time we have to take to stop the car is 2 seconds. So and we have to find s, that is the distance. So we use equation of motions, and we use the equation of s equals ut plus 1 by 2 at square. So this is s equals we have for this for first u and the time is into 2 into time is 0 equals plus minus 12, that is equals to the u is equals 12 meter per second. So we use now this formula, s equals ut plus 1 by 2 at square. This is u, s is equals u is 12 into time 2 plus 1 by 2 into minus 6 into 2 square, that is equal to s is equals 24 plus 1 by 2 into minus 6 into 4, 2 to the 4, s is equals 24 minus 6, that is equals to 18. Sorry, this is equals 6 into 2, that is equals 12, and this is going to equals 12 meter. So after the application of brake it travels 12 kilometer 12 meter, sorry. And thanks for watching. Here the rainfall is very heavy here, so I am ending the stream. So thanks for watching, and please like the stream, and thanks.